let me have your attention. I want to take a minute. Going back over things, there's really there was a pattern in graphs that I should have spent a little more time with. So I want to show you this. We went over one pattern in graph that you need to be able to recognize, but there's another pattern in the sciences, in high school science, that you're supposed to be able to recognize. Okay. So what we're going to talk about is the kind of patterns you can see in graphs. Yes, these are NOTESs. No, this is part of this unit. It will be on the test, but there was only part of it that I only went over half of it last week. So I wanted to make sure we cover all of it here. What numbers? On this? Oh, that's how many frames per second it's recording and how long I've been recording in one thing and another. All right, so the things that I've already covered with you are that your independent variable needs to go on the horizontal or x-axis. So you often call this the x-axis, but it's probably better to call it the horizontal axis. And then on the vertical axis, that's where you put your dependent variable data. And you sometimes call that the y-axis. Okay. So when you graph data from a lab or something, you always put the independent variable on the x and the dependent variable on the y. If when you graph the data, you'll have some data that will be shown on the graph. And what's the only kind of graph we allow in this class? Scatter graph, or dot graph, sometimes it's called. And so after we have the dots on here, then you need to have a best fit line or curve, right? All graphs need a best fit line or curve. This is what actually tells you what the pattern is. And the whole point for doing graphs is to figure out what the pattern is. Okay? It's been said that science is about figuring out the patterns in nature. Of course, it's more than that. It's trying to figure out why those patterns exist. So you first have to figure out what patterns there are, and then as part of that process, you're also trying to figure out why they exist. Okay? Now, this is, well, I've made it not perfectly straight. There's a little bump here, but it's supposed to be a straight line, okay? So this, if you have a straight line with a positive slope, I told you last week, this is called a direct relationship. It's a direct relationship between the data that you've measured or calculated for the x-axis and how it compares with the data you measure or calculate for the y-axis. A direct relationship. And what a direct relationship is, as x increases, it becomes greater, the value of y also increases. All right? So this then is a predictive pattern. And that's what graphs are all about. Graphs are about predicting this behavior in the future. If you were to test this same behavior with different data points or other samples, you should get something pretty close to the same thing you got before. That's the pattern. Okay? Now, whenever you have dots on here that show where the data points are, this is a best fit line or curve. Actually, this is a best fit line. So this is an example of a best fit line. And this best fit line is what actually is used to analyze the pattern between how the x-axis affects the y-axis, how the independent variable affects the dependent variable. Okay? So what you're using that best fit line for here is to analyze the pattern. So when you are writing your figure label for your homework, you're supposed to do three things. One was to tell me what was in the graph. One was to make sure that you're describing why that information is important. Usually that just means you're explaining how it is that x, whatever the thing is you have on the x-axis, the independent variable stuff, is affecting the y stuff. Okay? But then you also have to tell me what the pattern is in that relationship between x and y. You have to say that if you get a best fit line that's a positive slope like this, then you can say, because it's a direct relationship, you can say that there is a direct relationship between whatever you describe your independent variable as being on the dependent variable. That's an analysis. Yep.
Is that direct relationship?
No, direct. Direct. Like direct TV. Okay. Okay. All right. Now, I showed you all this last week. Okay. This is review then of this. All right. So the next thing we need to talk about is a different pattern that you must be able to recognize when you see this pattern. Okay. Kind of waiting on one person to finish up there. I can see it's still working on it. Got it? All right. Good. So let's look at another kind of pattern that you can get from a graph that you need to be able to recognize when you see it. Again, the independent variable goes on the horizontal axis. And the dependent variable goes on the vertical axis. And then you're going to take in all the data points will go on here as dots. Okay? But if the pattern of dots, once you try to figure out what that pattern is, and you put a best fit line or curve on there, you get a curve that looks like this. Okay? Huh? Well, it's not indirect, it's called inverse. Okay? It's an inverse relationship. And it's, you would describe this as being an inverse relationship between the independent variable and the dependent variable, or the independent variable has an inverse relationship with the dependent variable. Now, you wouldn't say that in an analysis. You would tell me what the independent variable is. Okay? So the force acting on an object has a, well, that's not correct. The pressure on a gas would have an inverse relationship with the volume of that gas. That would be one way. That's how you describe it. So independent variable would be pressure, dependent variable would be volume. Okay? So that's an inverse relationship, and an inverse relationship is one in which as the x value increases, y decreases. Now, this is not a parabola. This is not half a, you know what a parabola is, right? Yes? Okay. So it never goes back up over here somewhere. It doesn't go over the right, it doesn't swing up off the screen somewhere, okay? This is continuing to go down, 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 down forever to infinity, okay? So it's not a parabola. It kind of looks like half of a parabola, but it's not, all right? But this, then, is not a best fit line, per se. This is a best fit curve. And again, it is analyzing the pattern between the dependent variable data, the independent variable data as it affects on the dependent variable data. Okay? So those are the two patterns in high school chemistry you're supposed to be able to recognize by looking at it. If you see this pattern of data, you know that's inverse. If you see this pattern of data, you know that's direct. Got that? Anybody have any questions about that?